Welcome back, everyone. Today we're going to be looking at the heating of land and water and how they affect weather and climate. So I want you to find this page in your notes. Now hopefully you remember from a couple videos ago that the atmosphere is actually heated from the bottom up. We get energy from the sun in the form of sunlight or insolation, passes right through the atmosphere, hits the Earth's surface, which then absorbs it and releases it back up into the atmosphere. Well, today we're going to see that it doesn't get heated evenly. Land warms the air above it a little bit quicker. Water, on the other hand, warms the air still, but it does it at a slower rate. So as a result, during the daytime, you end up getting warmer air over land and colder air over water. Now, why do they do that? Well, it all has to do with a property called specific heat. And because of that, water is able to absorb a lot of heat before it starts to warm up. And here's a little experiment to show you water's ability to absorb heat. So there's something about water's specific heat that allows it to absorb a lot of heat energy. Here's a clip from Fuse School that'll explain more about what specific heat is.
You might have noticed that if you are trying to boil a lot of water, it takes longer than if you only wish to boil a small amount of water. This is all because of something called heat capacity. Keep watching to learn more. Before we get into details, it is important to realize that there is a difference between heat and temperature. Temperature is a way of describing how hot or cold an object is and is measured in degrees Celsius, whereas heat is a form of energy and is measured in joules. The more heat transferred to an object, the more its temperature will rise. So heat and temperature are related, but they are not the same. So what is heat capacity? The heat capacity of a substance is defined as the amount of heat required to raise the temperature of a material by 1 degree Celsius. However, what's more useful for us to think about is the specific heat capacity of a substance. This is, as it says in the name, a little bit more specific. It is the amount of heat required to raise 1 kilogram of a material by 1 degree Celsius. Different materials have different known specific heat capacities. To summarize, specific heat capacity is the amount of energy needed to raise 1 kilogram of a substance by 1 degree Celsius. It's helpful because it allows us to work out how much energy we need to heat up or cool down a substance to a desired temperature.
Okay, so let's go to your notes. Specific heat is the amount of energy needed to raise the temperature of a substance. So if something has a low specific heat, you don't have to put a lot of energy into it to get its temperature to go up. However, if something has a high specific heat, you have to put a lot more energy into it to get its temperature to go up the same amount. Page 1 of your reference tables lists the specific heats of some common materials. Granite and basalt are listed here, and they just happen to be the two most common rocks in the Earth's crust. Notice they both have a lower specific heat. They're both less than 1. What that means is that you don't have to put a whole lot of energy into them to get their temperature to go up. Liquid water is at the top of our chart, and notice it has a much higher specific heat than anything else listed there. So if you tried to raise the temperature of these materials by 1 degree Celsius, you would have to add a lot more energy to liquid water than you would to anything else listed there. Our next term is latent heat. Latent heat is the energy absorbed or released when a substance changes phases. In other words, it's stored energy. So what's the point of all this? I want you to take a look at the diagram in your notes. Remember, land and water are both getting energy from the sun in the form of insolation, or sunlight. because land has the low specific heat, once it starts getting that energy from the sun, it warms up fairly quickly and therefore starts to warm the air above it fairly quickly. Water, on the other hand, has a high specific heat. So if it's getting the same amount of energy from the sun, it takes a lot longer for it to heat up, and therefore it takes a lot longer to heat the air above it. So what do you think happens when the sun goes down? During the daytime, the land's been taking in heat quickly and getting rid of it quickly, so it doesn't hold on to it very long. So at night, when there is no energy source for the land, it actually cools off very quickly as well. Water, on the other hand, has been storing up its heat all day. It's taking in energy, but it's not giving it out very quickly. So at night, it still has a lot of heat stored up in it, and it still slowly warms the air above it. Okay, so let's finish off your notes by filling in these two columns on the table below the diagram. Land has a low specific heat, which means it absorbs and releases heat quickly. This will make the air temperature during the day warmer. But since the land's been releasing its heat quickly all day, at night it doesn't have much left over, so the air above it at night gets cooler. Now, if you remember air pressure from the last unit, you remember that warmer air creates lower pressure. So over land, the air pressure during the day tends to be lower, and at night it happens to be higher because the air is colder. Now, the conditions we're going to see over water are the opposite. Remember, it has a high specific heat, and what that means is that it absorbs and releases heat slowly. So therefore, the air temperature during the day is going to be cooler because it's taking in heat slowly and it's storing it up. It's not releasing it very quickly up into the air above it. So therefore, at night, it's still going to have a lot of heat stored up in it. And it still slowly warms the air at night, so we get warmer air over the ocean at night. And again, air pressure during the day, because it's cooler there, you get high pressure. At night, since it'll be warmer, you get low pressure.